Hello and welcome! Today we're going to take our garbage tour of the VDG and we're going to update it to work with the 6847 T1. I need your motorcycle, your helmet, and your boots. The T1 gives us a little bit more control over the border. It allows us to invert the entire display at once. And the coveted lowercase. The first change I made in the display modes array of the display mode struct is I got rid of the SemiGraphics 4 entries because they were pretty much the same. They had the same SAM bits, they had the same op mode control bits, so there was really no point. The SemiGraphics 4 mode is enacted on a character-by-character basis based on the high bit of the character byte coming in from the screen buffer, and has nothing to do with this stuff. That is something that I discovered a little bit later, and if you recall from my past video, I was quite surprised. I'm leaving in SemiGraphics 6 and up, even though, as I also discovered, 8 through 24 are quirks and were never meant to be used. And 6 no longer exists on the T1. See the other video that I'm posting after this one about the T1 datasheet for more information on SemiGraphics 6, but I've got to leave it in so I can see for myself. I've also added 3 new variables. These are basically just bits, but I'm wasting an entire byte on each one because I'm a wasteful person. This decides whether we want to enable the lowercase feature on the alphanumeric mode. This enables whether we want to use the reverse screen feature, which will change all the black on greens to green on blacks and vice versa. And this decides whether we want to enable the special background border feature, which changes the border from black to whatever the background color is for that mode. However, we must be cautioned, this does not work in all the alphanumeric modes, as my next video will go into detail on. These 3 bytes get toggled if you just hit the L or R or B keys while everything is going on, so you can watch the screen change as you hit the key. And the VdgDispModes subroutine has been modified to make use of those bits. So first off, it will use those bits on the name screen, so you can see on the name screen what's going on. On the graphic screens where these bits are not used, I just have a space. But when the alphanumeric or SemiGraphics screens are active, then we'll actually print that bit. We'll print either 0 or 1 in a certain spot on the name screen, so you'll see what the setting is. Those 3 variables need to actually make some kind of an impact. So now the op mode is going to be determined by what's stored in our struct for the op mode and those bits. So to start things off, we assume that the B register will be loaded with the original op mode byte. And again, this is what gets stored into FF22. When we're using the name screen, we're not going to be twiddling those bits, so B is just going to stay the op mode for the alphanumeric internal mode. But if we're showing the current display mode, then not only will we load B with the op mode as it was originally set, we will also change bits 4, 5, and 6, which relate to GM0, GM1, GM2, based on whether the user has chosen to toggle lowercase, reverse, or background border. So to use GM0 as an example, that's the show lowercase, we ask if the show lowercase variable is 0 or not. If it is 0, we want to reset the GM0 bit. So we jump to here and we AND it with this value that has a 0 in that slot and 1 everywhere else. Otherwise, we will OR B with this value that has a 1 in GM0 and a 0 everywhere else, and then we're done. And we do the same for reverse and background border. So now B is either the original op mode or it's the modified op mode based on those bits. And then at the end, we can store B into FF22. Another change is in the init screen subroutine. I added code so that instead of filling the entire screen with garbage, I actually reserve the first 256 locations to just be the bytes 0 to 255. And I just do that in this very simple loop over here. We start at the start of the screen buffer, and our byte starts at 0, and then we keep just looping and filling up that screen with bytes. So the garbage is only going to be after that. So if you're looking, say, at the text screen, that'll be about half the screen is going to be the bytes 0 to 255, and the rest will be garbage. But the higher resolution screens, the bytes 0 to 255 will take up less and less of a percentage of the screen. We will be running this using XRoar, which is what I usually do unless I'm debugging. And in order to run this with the new T1 VDG, you add this to your command line. If you just leave it out completely, then it defaults to using the original 6847. If you run both at the same time, the one on the left is the old original 6847, the one on the right is the T1, you can immediately see some differences. So on the left you see the square capital O, and here you see the round capital O. And if I were to type 0 in each one, you'll see that you get your 0 with the slash through it for the new one, and then a 0 without a slash on the old one. Now if I were to switch to lowercase, that ain't enough. You also have to actually go into the VDG and change the mode so you can see these as lowercase characters. But these other ways are kind of more immediate ways to tell which mode you're in, or rather which VDG you're using. So you notice in the top half we have the byte 0 to 255, and we got the garbage in the bottom half. So I'm going to first start with toggling lowercase back and forth. And if you take a look on the right side, the top row will toggle between the non-inverted capital letters and the inverted lowercase. I'm going to leave the lowercase on, and I'm going to toggle the reverse. And so you'll see now it's capable of doing the inversion of all the letters. I'm going to keep the reverse on, and I'm going to toggle the border, and on the right side nothing happens. Now with the reverse off, we're going to toggle the border, and you see we actually on the right side have control over the border, and it becomes the background, which is green. And so now I'm going to turn them all off again. And with them all off, I'm going to toggle reverse. And with reverse on, I'm going to toggle border. Nothing happens. With reverse off, I'm going to toggle border, and then we get our border. So that handles color set 0. Moving on to color set 1, we're going to do the same thing. Toggle lowercase. With lowercase on, toggle reverse. With reverse on, toggle border, nothing happens. Reverse off, border does something. And then with everybody off, we're going to start toggling reverse. With reverse on, I'm going to toggle border. With reverse on, I'm going to toggle border, nothing happens. So you'll see on SG6 on the right side, it's the same. There's no difference. That's because they told us they removed SG6. But just to double check, lowercase, reverse, everything looks the same. I'm just going to pause it here for a second. You may have noticed that when we switched to SG6 on the left side, it also seemed to revert back to alphanumeric internal, whereas you may have recalled from before I made any of my changes, SG6 really was a different screen on the old VDG. Well, if you take a look at what the operating mode bits look like, alphanumeric internal is all zeros, SG6 is the same except there's a 1 in bit 4, and that is the lowercase bit. So you might have noticed that when I was on AI on the left, when I hit lowercase, it made a drastic change. It actually switched it to SG6. And then when we moved to SG6, we start off with L, R, B all being 0. So we actually started off with the same bits as AI. And then when I started flipping L, you probably noticed that it changed there as well. Just wanted to let you know that's what was going on if that was confusing. And then SG6 with the color set changed, same as the other one. Really no need to go through all of that. Here we are at SG8, basically just like in the old, it was never supposed to exist. It's just a silly quirk. But you can do weird things, like if you look at the top half, it looks like pieces of the alphabet are like trying to get assembled. And if we do like lowercase, you can see like some things that were green on black kind of invert because the lowercase is the inverted and the green on black is the non-inverted. If I leave that on and I do the R to reverse everything, you can kind of see this is like just silly. Leave them both on, the border does nothing, leave off reverse, and then the border can do stuff. And if I just do reverse, leave reverse on, and I do the border nothing, reverse off, the border does something. Here we are at SG12, and it's a similar story, it just looks a little different. We're doing the lowercase now. Reverse. Border. 24. It's actually interesting leaving the stuff that's untouched, adding that to reverse and seeing what you get. I don't know why I would do that, that's just weird. Now we're finally on regular graphic screen. So at this point the lowercase, reverse, and border have no effect. So I'm not going to do anything with them, but we're going to run through these. Well, I hope you enjoyed the garbage tour of the T1. There are a couple companion videos on the way. The first one that I'll be posting after this will be an examination of the data sheets of the 6847 and the 6847 T1, noting the differences in the hardware. And then after that, I will be talking about the code that I used to handle the keystrokes so that you can type L or R or B and get those changes activated into the VDG. As always, you can find the source in the link in the description so you can try it out for yourself and make whatever changes you like. Thanks for watching, and I'll see you next time.